Fusion Mobile, quality e-learning experience on the go.
You're welcome back. For this class, we shall be considering measures of central tendencies. Alright, so we're talking of measures of central tendency. Okay, and won't be taking much of your time in explanations, and so we'll be going into discussing the measures. The measures includes number one, the mid-range, the one you call the range. Number two, talk about the median. Talk about the median. Talk about the mode, and then we'll talk about the mean. Okay, we'll start with the mid-range. The mid-range. Okay, it is the number halfway between the smallest and the largest observation. Okay, I will use formula to define this. Mid-range is equal to the smallest number plus the largest number, okay, divided by 2. Alright, so when we say half, we mean 2. Okay, so for example, if you're given the set sub value, consider the sample. We have samples of number 5, 3, 7, 6, and 5, and 6, and 4, and 8. Okay, fine. The mid-range will be equal to the highest number there is 8, the lowest number there is 3, divided by 2, which will give you 11 over 2, and it's 5.5. Alright, we're talking about the mode. The mode in a data set is the observation. Okay, is the observational number which occurs most often. Okay, the number which occurs most often. Okay, or you can say it's the number with the highest number of frequencies. Alright, and so for example we have to consider the sample. 2, 4, 5, 4, 6, 4 again, 7, 5, 4, and 6. Okay, just look at the number there. You find out that there are repeated occurrences of 4 occurs 1, 2, and 3 times. 5 occurs 2 times. Okay, then the 4th time you have 4, 4, 4, 4. Alright, the frequency of 2 here is, if you want to group them according to frequencies, okay, and the numbers. Alright, frequency of 2 is 1, frequency of 4 is 4, and then the frequency of alright, let me make this look better. Alright, okay, all I'm saying is this. Back to my writing pen. Alright, so all I'm saying is this. If you want to group them according to frequencies, number and frequency, the number 2 has the frequency of 1, the number 4 has the frequency of 4, the number 5 has the frequency of 2, and then the number 6 has the frequency of 1, same with number 7. So the highest occurring number here is 4. So therefore 4 is equal to the mode, or you can say mode is equal to 4, because it occurs 4 times. It has the highest number of occurrence. Okay, the mode is defined by formula. Okay, the mode is defined by formula for ungrouped data. Sorry, the mode for grouped data is defined by formula. That is for grouped data. Rather, it's given us this mode equal to L, which is the lower class boundary, plus the division of this. Okay, and put a division line at that point. Fine. Alright, FM, where FM is the frequency of the model class minus FM minus 1, frequency of the class before the model class, over FM minus FM minus 1. We already know this too. Alright, plus FM minus FM plus 1, the frequency of the class after the model class, times C, where C is the class interval or class width. Alright, so I will still write this as the lower class boundary. Okay, and then FM, frequency of the model class, okay, and then FM minus 1, which is the frequency of the class, or the class before the model class. Okay, class, and then FM plus 1 is the frequency of the class after the model class. Okay, and then C is the class interval or the class width, what we call the class width. Okay, we'll still talk about all these things, and then go over to the median. Alright, when observations are arranged in their order in array, okay, from the smallest to the lowest, okay, make sure you arrange your observations. Make sure observations are arranged in ascending order. Ascending order, that is from the smallest or from the lowest to the highest. Alright, and so when observations are arranged in this order, okay, assuming the observation is odd, okay, or with the median, if observation after arrangement the total number of observation is odd, we mean is an odd number. Okay, good. Then we have to take the middle number. If observation is odd, the middle number is the median. The middle number after arrangement, okay, is the median. And what if observation is even? And if observation is even, then the median is the average of the two middle numbers. Okay, then median is the average of the two middle numbers. Okay, what we are saying is this: the median is as good as getting the two middle numbers, add them and divide by 2. Okay, all right. The median as well can be obtained using the Ogive curve, and also you can use your histogram to obtain a median. We take for example, let's take this example. For example, you're given the sets of values 24, 29, 33, 22, 27, 36, and 42, and 47, and 43. You have to find the median. Okay, so how you go about this, you have to arrange in order. You can arrange in ascending or descending order. But in ascending order, 22 comes before 24, and then 24 follows. Look at the numbers very well. 27 comes, and then 29 comes. Okay, and then 33 comes, and then 36. Okay, and then you have 42, 43, 47, and so these are the numbers we have. And so the median, you count your numbers. If they are odd, then the middle number is the median. 1, 2, 3, 4, 5, 6, 7, 8, 9. They are odd, so the fifth number is the median. 1, 2, 3, 4. Yeah, that's the middle number, because in front of it you have 4 numbers, behind it too you have 4 numbers. So therefore median is equal to 33. And suppose it is an even number, how do we find the median? Okay, we'll take example, second example, example 2. Okay, suppose it's an even number. You are given 24, 29, 33, 22, 37. Sorry, yeah, list is 37, 36, and 42. Alright, solution to the same thing we did above. You arrange in the ascending order. You have 22. Try to cancel out 24, 29. You have 33. Then it's out. We have 37. Sorry, 36. And then 37 and 42. So you have 1, 2, 3, 4, 5, 6, 7. Okay, you have 7 numbers. Is that right? Alright, so let me include another number, 47. So we make it 8, 47. So we have 1, 2, 3, 4, 5, 6, 7, and 8. Alright, two middle numbers are 33 and 36, because if you make them the middle numbers, the numbers will be divided into 2. We having 3 on our right, left, and then 3 on our left, numbers that are left there. And so we have therefore the median at this point will be the average of the two numbers, that is 33 plus 36 divided by 2, which will give us 69 over 2, which is equal to 34.5. So this is the median. Okay, so we're going into definition of the mean. We're going into definition of the mean, and so we'll define the arithmetic means. Alright, arithmetic mean. Okay, is simply called the mean. You can also call it the mean. Alright, let me define this as mean as the sum of observation. Okay, let me say the ratio of the sum of observation. Okay, the ratio of the sum of observation to the total number, total number of observation. Okay, the ratio of the sum of observation. Okay, so the mean x bar is equal to mathematically sum of observation, okay, all over total number of observation. Okay, so all we are saying here is that for example, example 1 on means, you are given the sample (24, 35, 52). Sorry, let me use. Okay, let me use 54, and then 32, 27. Let's take 43, 48, and 58. Okay, I have to find the sample mean. Find the sample mean. All right. So how do you go about this? Remember that the mean. Let me go back and make some adjustment to the definitions. Okay, sum in mathematics is given as this symbol. Okay, observations could be in the form of x1, x2, and so since observations are in this form, we call this sum x or summation x. Total number of observation is sometimes denoted as n. Okay, all right. Look at this, and mean itself is x bar. Okay, represented as x bar. So solution we have observations x1 equal to 24, x2 equal to 35, x3 equal to 54, then x4 32, x5 27, x6 equal to 43, okay, x7 equal to 48, and x8 equal to 58. It's not necessary that you first start to denote by x6. Okay, it's not that necessary. Why I'm doing this is because I want to justify this equation, mean s bar is equal to summation x all over what n. Okay, where n is equal to the total number of observations. We have 8 observations. Okay, all right. Summation x is equal to summing all the observations. You have 24 plus 35 plus 54 plus 32 plus 27 plus 43 plus 48, and then it continues plus let me try and fix 58 at this point just to make that clearer. All over the total number of observation is 8. Alright, so all we are saying is that summation x over n 24 35, 54, 32, 27, 43, 48, 58. Okay, all divided by 8. Alright, so when we sum all these numbers with your calculator, you find out that the outcome we got 398. Okay, is that right? Wow. Okay, it should be 398. I think let's do that again. So we'll have 321 divided by 8. 321 divided by 8. When we carry out the division, it will be equal to 40.125. Alright, so this is the mean of these numbers. Okay, you can approximately write this as 40.13. Alright, so this is what we call the mean of these numbers. Alright, so there are other methods of calculating means, both for grouped and ungrouped data. There are different methods for calculating means of group data. There are also different when we talk of group data, we talk of data that have been classified into frequencies. Or when we talk of ungrouped data, we talk of data that have not been classified into frequency. If you check on this slide, you will see where I tried classifying into frequencies at this point. Okay, so when data are classified into frequencies, they are called grouped data, but when they are not, they are called ungrouped data. So in our next class, we'll be looking at the natures of group data, how their mean and their range and their median and the rest are obtained. Have a nice day.